So 5-2 properties of exponents and radicals. Now, you guys were using a lot of these properties yesterday and have been using them. So this is kind of redundant. But the next slide is just a review of the properties. You don't have to write it down if you don't want to. We were already doing them. I think it's rare that it reviews them now. So my pen doesn't work.
I don't need to write this down.
That's up to you. Okay. So product power. So I have a to the m times a to the n. What do I do to my exponents? Add them, right? Were we doing that? Like, we know how to do that, correct? Okay, but with rational exponents, we add them just the same. But if they don't have common denominators, guess what we have to get? Common denominators. That's it, right? Yeah. So when I divide exponents, I do what with them? Subtract them. So when I divide them, now my pen is working, I subtract them. So I have 3 to the 4th divided by 3 to the 2nd is 3 to the 4 minus 2. So 3 squared is 9. You know this, correct?
Yeah.
Okay. So a power to a power, what do you do with the two numbers? You multiply them. You had to do that in your assignment yesterday, didn't you? Okay. So if I have a fraction, the 2 reduced, or the 3 is reduced, and you had 7 squared, which is 49. Now, we also had to do this one yesterday also. And I think maybe I told you to do it because there's no point not to do it. If you have AB to the M, you distribute your M, don't you? Yep. And you have A to the M, B to the M. And the same thing here, you distribute this 1/2 to both, and half is square root, correct? Yep. So the square root of 16 is 4, plus or minus 4. Good job, Cadence. And they didn't put their plus or minus, did they? Plus or minus 4, and then we'd have x to the 1/2 because there's a 1 on this x, isn't there? Okay, negative exponents, we also did this one. What do? They reciprocate. So what happens if I had 1 over a to the negative m? It'd just be a to the m over 1, right? Yeah. Okay, so we used every single one of those yesterday, didn't we? Yeah. What? Not at all. Not one of them. I guess if you didn't do your homework, you didn't use them.
She didn't do it.
Yeah.
Okay. So guess what we're going to do? We're going to use them. So I have 81 to the 5/6 times 81 to the negative 1/3. So my bases are the same, correct?
Any common denominator.
Oh, shoot. Just a second. Okay. So I have 81 and I have 81, correct? So I have common bases, so it's going to be 81 to some power. And yes, we have to get a common denominator. So first of all, I have a positive and a negative. My answer is going to be a... Negative. Oh, wait a second. We're adding. Never mind. Okay, so what's my common denominator between 6 and 3? 6. So 1/3 is going to become negative...
2/3.
Negative 2/3.
Yeah.
6. 6. I'll go with the 2, but not the thirds. Okay, so then I have 5 minus 2 is 3/6, or 81 to the 1/2, which is plus or minus 9. So anytime I have an even root, how many answers are there? 2. Anytime I have an odd root, how many answers are there? 1. Okay, so now I got a whole bunch of stuff. Now, if 3 and 32 were alike, could we divide them right now?
Yeah.
Yes, but they are not, are they? So I can't divide them. I have to do what with my exponent? I've distributed, yes? Yeah. So I'm going to have 3 to the 1/2 over 32 to the what?
1/5.
To the what?
1/5.
How'd you get 1/5?
1 times 2 is 2. 5 times 2 is 10. 1/5.
Okay. Or you could have it's 2/5 times 1/2 and the 2's reduced, correct? So I need the 5th root of 32, which we should know.
2.
2. We've done it enough, right?
Yep.
So because this is 2 to the 5th to the 1/5, so it's 2. And this would be 1/2 would be the what? Square root of 3. Are we good?
Yeah.
So is it more of just manipulating of what you've already done?
Yeah.
They just combined a couple things. Okay, so now we do have an x and an x, don't we? So we could simplify those first. The x in the numerator has a 1. Doesn't it?
Yeah.
So I have x to the first divided by x to the 1/2. So I could divide those, yes?
Yeah.
Okay, when I divide I,
Reciprocate and multiply.
nope, not exponents. When I divide exponents, I
Subtract.
subtract them. Okay, which one's bigger, 1 or 1/2? 1. Because we can't have a negative exponent when we're done, so we always want to go to the bigger number. Whether it's in the numerator or the denominator, we want to go to the bigger number, okay? So we're going to take 1 minus 1/2, which is what? 1/2. So I have x to the 1/2, y cubed, all to the what?
2/3.
2/3, and then I have to distribute these in. So 1/2 times 2/3 is 1/3. Okay, and then 3 times 2/3 is 2. So y squared is no longer in a root, is it? Is it? But this is a what? What root? Cubed root. So we have y squared, the cubed root of x. Now, the reason why I keep putting these things in radical form and exponential form and radical form and exponential form is to keep our brain doing it. Okay? Now, they may end it here, which is fine, but if I move it, doesn't this look neater? The last one we left it as? This looks neater, doesn't it? Yeah, I know. Okay, what are we going to do first on this one?
Distribute 2/3.
We're going to distribute the 2/3 into both, correct?
Yep.
So I have 2a to the 1/3 times a to the what? A to the 2/3, because there's a 1 on there, right? B to the 1/3, because the 2's reduce. So now what? I basically just multiply, right? So there's a 1, so 2 times 1 is 2. We're going to have a to the what? I have 1/3 plus 2/3 is 1. And b to the,
2/3.
no. Is there any other b's?
No.
No. 1/3. So I have 2a times the cubed root of b. So I'm just multiplying and using the rules that we were using already, but I'm stacking them on top of each other. Not too bad, is it?
Is that all?
Not sure. Am I good?
Yeah.
Okay, same thing. Okay, now instead of the rational exponents, I have them in radicals. But couldn't I just put them in rational exponents? Yeah. So, oops. So, let's see. Probably if I'm going to have to reduce, I should probably break down 16, shouldn't I? 4 squared, how about 2 to the 4th? Isn't it 2 to the 4th?
Yeah.
And then x to the 5th, and it's all to the what? 1/3. So now what am I going to do to that 1/3? Distribute it. And I'm going to have whole numbers and remainders, aren't I?
Yeah.
So this is where I have to break it up. Whole numbers and remainders. So 4 times 1/3. How many times does 3 go into 4? 1 time. with what left over? 1/3 left over. Because 1 plus 1/3 is 4/3, isn't it?
Yep.
Okay. So then, how many times does 2 go into 5? Once. With 2 left over. So 2/3. So the 2 and the x are out of the radical, correct? And I have the cube root of what? 2x squared. So I did this stuff a little bit with you in the last section, when they weren't really saying, oh, don't do that yet. But did it make sense to wait? No, we were just doing it anyway. Okay, so we're going to do the same thing, right? Can I reduce before I put it into a... Well, I'm talking this x and this x. Can I reduce the x? Yeah? So I can reduce this x, and this goes to what? 3? So I have x cubed y squared over what? What's 125? 5 cubed? All to what power? To the third. And now I distribute it, correct? So 3 goes into 3 how many times? 1. So I can have x to the first. Does 3 go into 2? Nope. So I have y to the 2/3. And my denominator, does 3 go into 3?
Yeah.
1 time. So my answer would be x, the cube root of y squared over 5. See how those exponents make it easier to work with?
Yep.
It may add a little bit of a step, but it does still make it easier to work with. Okay, now what am I doing the next one? The 4th root of 81, a to the 4th, b to the 5th. Tyson, what can I do with 81?
9 goes.
9 squared, right? But if it's 9 squared, then it's 3 to the what?
3rd, 4th.
4th. So I have 3 to the 4th, a to the 8th, b to the 5th, all to the what? 1/4. And then I just distribute it in. So 4 goes into 4 how many times?
4.
Once? Did somebody say 4? Okay, I know. And then 4 goes into 8 how many times? Twice. So it's a squared. And it'd be b to the first with 1 left over. Okay, so yep, 3a squared b, the 4th root of b. The only thing, Savannah, you said to the 4th root. To the would be an exponent, right? I don't think you knew you said the word. You said 3a squared b to the 4th root of b. To them means an exponent. That's all I was trying to say. It's just you added in there because you were used to saying the exponents.
What is it called?
That's okay. What?
What's it called then?
4th root. She just had the 2 in there. So it's 3a squared b, 4th root of b.
That just sounds weird.
Yeah, it does. Or you can say times the 4th root of b if you want to say something in between it. Okay, but it's not to the, because if you say to the, then that'd be an exponent. And I will tell you, there will be exponents of the 4th root of b. Like, that is such a thing. Okay, so rewrite product quotient, same kind of stuff.
Oh.
So 16 to the 5th root of 16, what should we do with that?
Take 16, square root it, 4 squared. What times was it?
Not 4, keep going. 2 to the 4th. Keeps jumping on me.
4 times
2 to the 4th, to the 5th,
2 and 4 fifths.
2 to the 1, 2 to the 4, whatever. I can't talk. 2 to the 4th to the 5th.
2 to the 4/5. 4.
Yes, it's 4/5 altogether. You were right.
Yeah.
Okay, and the next one is going to be 2 cubed to the what?
1/5.
1/5.
That's 2 to the 3/5.
But I have 3, 4, and I have 3, so I have how many?
Oh, 7.
7. So I have 2 to the 7th to the 5th. You see what just happened there?
Yep.
Now, could I have done this if my roots weren't the same? No.
No.
My exponents are the same, so I can mess with those bases. Okay, so 5 goes into 7 how many times?
1.
Once. With what left over?
2/5.
2/5. So I have 2, the 5th root
Of 2 squared,
of 2 squared,
which is 4.
which is 4. So 2, the 5th root
Of 4.
of 4.
Cool.
Okay? You guys want to try this one on your own?
Yes. Okay, that's fine.
Try it. I think we only have 2 more after this.
Can we multiply the denominator by 1/5 too?
Mm-hmm. You mean to the power of the 1/5?
Yeah.
Yep.
Hey, would you leave 7 as 17 first?
Hmm?
Would you leave 7 as 17 first?
I would make it 7 to the 5th. To the 1/5.
Well, like, before you get there.
Oh, yes. Yes.
Oh, you didn't think that.
Oops.
Is that the final answer?
Can I do anything with that?
I don't think so.
Yes, you can.
Can I leave a radical in the denominator?
No, you can't.
That's a
No
no-no.
solution.
No. We got to do something.
No solution.
We got to rationalize.
You better not
Maybe
be
we're supposed to
racist.
do this on our own.
Yes.
I
Okay.
was right.
So, we have to rationalize. Let's just see how far we got. So, if I have 1/5, how much do I have to add to it to get to the next whole number? 4/5, right? So, I have to take the exact same thing that I have, which is 2 to the 4th, x to the 3rd, but to the what? 4/5. And if I multiply the denominator, I have to multiply the what? Numerator. Kyson, why are you distracting Riley? She can't be distracting you because you're the one turned around. If you weren't turned around, she couldn't distract you.
I was looking at the board and she was like this.
Yeah, I'm sure. Okay. So whatever I multiply the denominator by, I have to multiply the numerator by, correct?
Yeah.
Okay. So now just looking at this denominator, I have 1/5 plus 4/5 is what?
5/5.
Which is 1. So is my radical gone?
Yes.
Yes. So my denominator is 2 to the 4th, which we already know is 16, x to the 3rd. But my numerator is everything involved is to what power?
4/5.
Oh, this is 4/5 and this is what?
1/5.
1/5. So we're going to have a problem, right? So I got to do some work. So I have 7 to the 1/5. I have 2 to the what? Power to a power. So 4 times 4 is what? 16. So I have 16/5. And then I have x to the 12/5. So the denominator is done, correct? There's nothing else I can do with it, so I can just keep carrying it along.
You need a numerator?
What?
No, she needs the
Denominator. In the numerator, I have 7 to the 1/5. So am I still going to have the 5th root hanging around? Yep. Okay, so let's look at this. So I have 7, right? Goes in there. How many times does 5 go into 16?
3 times.
3 times. So I have 2 to the 3rd. And how many left over? 1. So 2 to the 1st inside the root.
So 14.
Okay, we're not done yet. How many times does 5 go into 12? 2.
2 left over.
So x squared with how many left over? 2. So x squared. So I now have 2 cubed, which is 2 cubed.
8.
Oh, actually, isn't 16 2 to the 4th?
It is.
So if I have 2 cubed over 2 to the 4th,
You have 2
I have 2 in the denominator, and that's it, right?
and 1.
And then I have x squared over x cubed.
And then that's
So that's,
1.
and we have 1. So in my denominator, I have 2x. And all this reduced to 1, didn't it?
Yep.
So I now have just the 5th root of
So 14x squared.
14x squared. So that took a minute,
Yeah.
Took like 2 minutes.
maybe. But as long as I follow my rules and what I was doing,
Look at that board.
as long as I follow the rules and what I'm supposed to do and don't try to make them up, did I try to do this all at one time?
Nope.
Nope. Okay, I think we got 2 more. And they're just practice of what we just did. Okay, what root do we have?
Can we do it ourselves?
Sure. Second one's gonna be easier than the first one, maybe. Oh, maybe not.
Stressing Cole out has
Hmm?
been. You're stressing Cole out.
It's my job. I do it well.
Don't you think it'd be better to have stress-free math?
Is there a thing?
No.
There could be.
I doubt it.
It gave us the answers to everything.
It's like a unicorn.
You're supposed to be working.
Did you write yet? No. Do you? How do you know what we're doing? Usually
How'd it go, guys?
bad.
Bad?
No.
I got
Okay.
answers.
So did you separate the 1/3 and the 1/3?
Yeah.
Yeah. Okay, so what do I have to add to 1/3 to get to the next whole number? 2/3. So I have 9m to the 2/3, 9m to the 2/3. Because all I'm doing is multiplying by 1.
Yeah.
Isn't this just 1?
Yeah.
Yes. So now I have 1/3 plus 2/3 is 3/3, so my denominator was just 9m. Okay, now I've got to do the numerator. Well, I notice that my root is 3. Yes? Third root. So I need to distribute the 2, don't I? So I have 2n times 81 times n squared. Because there's not going to be any cubes in there. There's no perfect cubes in there. So 2 times 81 is 126
162.
or 162. Thank you. M squared n, and it's all the what root? Cubed root, or the third root. Are some of them going to be harder than others?
Yes.
Yes. You need to start them at least. Okay? Try something. Put a question mark on it. We can work on it. But if you guys don't try anything, I can't help, can I?
No.
Okay, what do you want to do with the next one?
Delete.
I agree with Bladen.
What do I do to 27?
Make it
3 cubed. And then I'd have x to the second, all to the
1/4
1/4.
times 3x to the 4th.
To the 1/4.
Are they both to the fourth? It's on the first one.
Oh, that's one, not 1/4. It's one, what? Half? How do I know this one's 1/2?
Because it's just squared.
Because it's just a square root, right? Okay. It says rewrite the product or quotient. Well, can I do anything with this?
No.
Possibly.
Well, I should distribute this, correct? Yes?
Yes.
And this.
Yes.
So that gives me 3 to the
3/4.
3/4,
X to the 1/2.
x to the 1/2
3 to the 1/2. And x to the 1/2.
times 3 to the 1/2 and x to the 1/2.
And then distribute.
And then I'm multiplying, right? So I have x to the 1/2 times x to the 1/2 is x to the
1/4. Wait, no.
1. Because it's 1/2 plus 1/2, correct?
It's 1/2.
So it's 1. Now I have 3/4 and 1/2. What do I have to do?
Your common denominator.
Common denominators.
It's 5.
So this would be 2/4. So 2/4 plus 3/4 is,
5/4 is 3, and then 1/4.
so you have 5/4. So yes, 4 goes into 5 one time with 1 left over.
And then x.
So I have 3x, the 4th root of
3.
3. So it's all about the manipulation of the numbers, guys.
That wasn't bad.
No, it wasn't bad, but when you first thought, you're like, oh, I can't do anything to it. But could we? Yes. So is it going to take some, well, let me try this and see what happens.
No.
Yeah.
Brain power.
Brain power. Stretching our brain.
Can you use our work on?
Whoa.
Yeah, I don't think I have adding and subtracting on there. We can cover that on Monday. Okay, if your assignment has adding and subtracting on there, just worry about the other ones, okay?
Okay. Thank you.
You're welcome.